So we're going to talk about absolute value in open sentences. The absolute value is the distance from 0. So the absolute value of x is equal to 3. That means that we are 3 units from 0. It means that x could be equal to 3, or x could be equal to negative 3. From 0, we are possibly 3 units away from 0. So it's either 3 or negative 3. What about the absolute value of x is less than 3? So let's look at our number line. That means that instead of being right at 3, it cannot be 3, but it can be anything less than that. Or in the opposite direction, it cannot be negative 3, but it can be anything less than that. So looking at this picture, that means we have a conjunction that x is less than 3 and x is greater than negative 3. You could combine that all to be, just starting with this one going the other direction, 3 is greater than x, which is greater than negative 3. You could also list it in the reverse order and say that negative 3 is less than x, that is less than 3. Now, what about if the absolute value of x is more than 3? So starting from 0, we have to be at least 3 away, but we can be a lot more. Or we could be 3 away in this direction, or a lot more. So that looks like a disjunction. That's an or. So either x is greater than a positive 3, or x is less than a negative 3. So what does that mean when we start looking at these absolute values? If it's a less than, it's going to be an and. It's going to be a conjunction statement. You're going to have all the distance in between. If it's a greater than symbol, then it's going to be a disjunction. It's going to be an or. You're going to go in both directions, opposite directions. So on a number line, the distance between the graphs of two numbers, a and b, is the absolute value of the difference. So when you subtract them, and it doesn't matter if you do a minus b or b minus a. So on a number line, you have a and you have b. The distance between them is a minus b or b minus a. You're taking the absolute value of the distance between them. So then let's look at an example. We're going to solve this one by graphing. Y minus 3 is equal to 5. This is y that must be a number whose distance is 5 away from 3. Because we're subtracting, right, that a minus b, that's the difference between the numbers is 5. And it can go in either direction. So the distance between y and 3 is 5 in either direction. So we start at 3, this is our start, and we say that it's 5 in either direction. So it's 1, 2, 3, 4, 5, or it's 1, 2, 3, 4, 5 in this direction. We could also solve it by saying if the absolute value of y minus 3 is 5, then either y minus 3 is equal to 5, or y minus 3 is equal to negative 5. So up here, that very first one, we said when it's 3 units away from 0, it's either 3 or negative 3. Here, we're going to set what's in the absolute value equal to 5 or negative 5. At this point, you have two equations, and you can just solve both of them independently. Y is equal to 8, or y is equal to negative 5 plus 3 is negative 2. So that's exactly what we found on our graph. Now we're going to write the disjunction for this one. Oh, that's what I did right up here. Writing the disjunction is taking it out of the absolute value and giving the two possibilities. It's this one or it's this one. Okay, so example 3, let's solve this absolute value and graph the solution set. I'm going to start by looking at this and saying, if I'm looking at the distance or the difference between two numbers is less than 6, my difference is subtraction. This is the same thing as x minus a -2. So the distance between x and -2 is less than 6. So to graph it, I could start right here and I could say 6 away on this side. 1, 2, 3, 4, 5, 6 is right here. It could be equal to it or anything less. And then 6 on the other side, 1, 2, 3, 4, 5, 6, it can be equal to that or anything less. So that's how I would graph it. But now I can write either a conjunction or a disjunction and check my work. When the distance is less than or equal to, or just less than, then it will be a conjunction. It's an and. It means that all of that is going to connect. It can be teeny tiny close to it, or it can be up to 6 away. So writing my conjunction, I'm going to do x plus 2 is less than or equal to 6. And we know that we're going to use -6. But what I didn't tell you is that when it's not equal to, when we do that -1, we need to switch the sign, switch the direction of your inequality. So I'm going to say that x plus 2 is greater than or equal to -6. Now I can go about and just solve these both the way that we have been practicing how to solve. And then I have an and when I do that over here, -6 and -2 is a -8. So let's check our work. X is less than or equal to 4. So here it is at 4, less than. And x is greater than or equal to -8. Here it is at -8, and it goes forward. So we have two ways to think about it now. The distance between x and -2 is less than 6. Or we can write them both out, where we would take away the absolute value, and it's either 6 or -6. When we use the negative, we switch the direction of the inequality. So let's start with this one, just writing the algebra about it. So y minus 4 is greater than 3. So we can take that one, write how it is. And now y minus 4 is going to be less than -3. I'm going to add 4 to both sides. I get y is greater than 7. And over here, I get y is less than 1. Now, is it an and or an or? Honestly, it doesn't matter. When you start to graph it, you'll see which one it is. But I will point out that when we said that it was greater than or greater than and equal to, that it would be a disjunction. It would be an or. So y greater than 7, so it's not equal to 7, but it's bigger than 7. Or y less than 1, so not equal to 1, but anything less than it. And you can see that's a disjunction. There's two parts. Either one works. Last one, 7 minus x, the absolute value of, is greater than 2. So before we had talked about if we have, x minus a number, then it's the distance between x and that number is the answer. But this time we have 7 minus x. Do I still go to 7 and say that we're 2 away from 7? Actually, I do, because remember at the beginning we said that a minus b, the absolute value of it, was equal to the absolute value of b minus a. So just because I have the number first and the variable second doesn't mean it's any different. So I could go to 7 and I could say 2 away is 9. It could be equal to or bigger than, and 2 away on the other side equal to or bigger than. Now I can double check by writing it out algebraically. Because it's a greater than, it's going to be or. And I'm going to switch the direction of my sign when I write the negative version. Now I'm going to subtract 7 on both sides, and I get negative x is greater than or equal to negative 5. Now, before we would just say, oh, we're going to, take away both negatives because there's a negative on both sides. But we have to think about what we really did when we did that. You could think of it as multiplying or dividing by a negative 1. When I divide with inequalities by a negative value, what do I do to the inequality? I have to switch the direction. So this is now x is less than or equal to 5. And that's exactly what this part of our graph shows. So let's make sure the other one works. If I subtract a 7, I get negative x less than or equal to negative 9. Now, if you don't want to remember about the multiplying or dividing, I could think of it this way. I could think of adding the x to both sides. So now I have 0 is less than negative 9 plus x. Now I'm going to add 9 to both sides. And I get that 9 is less than or equal to x. So I didn't have to flip the direction of the inequality, but I just moved where the x and the number were. And if you see, if I write it the other direction, x is greater than or equal to 9, it really did switch directions, as though I was dividing by a negative 1 here and switching the direction of the sign. So this part of the graph shows that x is greater than or equal to 9. Okay, now we're going to start with lesson 10.6. This is absolute value of products in open sentences. So really there's not much different here if we solve them algebraically, but the graph is a little bit different than just pulling the numbers out and the distance away. So let's look at this one. If we write the disjunction that this is equivalent to, it's just the same as the other one. 2x minus 4 is equal to 8, or 2x minus 4 is equal to negative 8. And we can solve it that way. If we add 4, 2x is equal to 12, divide by 2, x is equal to 6, or over here, negative 8 plus 4 is going to be a negative 4. So 2x is equal to negative 4. I divide by 2. It's an equal sign, so I'm not flipping any direction. And it's this. So then let's look at how we can look at the distance. Before we had said the distance between x and the number is the subtraction is 8 away. But if we did that, we'd be saying the difference between x and 4 is 8 away. But it's a 2x, so it's twice as small as what we would pull out by ourselves. You could also think of it as, what if I wanted to take this 2 out in front? Then it would be 2 times x minus 2 inside parentheses is 8. Then I could divide this 2 out and have x minus 2 in the absolute value is equal to 4. So it's my distance of 4 between x and the number 2. So if I go to 2 as my start and go 4 away, I'd find that's exactly what I got algebraically. If this distance thing is getting a little confusing, it's okay. Solve it algebraically and you will be able to put them on the number line that way. Hopefully it made sense in the last lesson, but then when we start to try to divide out how big x is, or here again, the distance between 10 and 2h, so I could factor out a 2 and solve it that way. or I can just take each of them and write my disjunction in this case, because the distance is greater than or equal to 6. So that means I can have an or 10 minus 2h. Now remember, I'm going to switch the direction of my sign when I use the negative value. I'm going to choose to work this one by adding 2h to both sides. And I'll subtract 6. And now last, I'm going to divide by 2. Or doing the same thing over here, add a 2h and add a 6, add a 2h and add a 6. Adding a 6 here is going to give me 16. 2h divide by 2, and I get 8 is less than or equal to h. So now when I graph it, I need to read them in the opposite direction. So h is less than or equal to 2. So it can be 2 or anything less than that. And h is greater than or equal to 8. It can be 8 or anything bigger. All right, our last one here. I'm just going to write it out. 1 plus 8d can be greater than 23. With a greater than, it's going to be an or 1 plus 8d. Now I switch to a less than and a negative 23. Now I'm going to subtract 1. Divide by 8. So d is greater than 22 over 8. And 22 over 8 is the same thing as 11 over 4. So that's really close to 12 over 4. 12 over 4 would be 3, so it's a little less than 3. And that's an open circle, and d is bigger than that. So we're going to go that way. Over here, I'm going to subtract a 1. 8d is less than negative 24. Now I can divide by 8. d is less than negative 3. So it can't be negative 3, but it can be anything less than that. And you see our disjunction in how we graph in opposite directions.